Tonight you're going to work on relationships in triangles. These are called altitudes, bisectors, and medians. And they tell you very important things about triangles. The altitude is the first one we'll look at. It represents the perpendicular height of a vertex, how high the vertex is. If you think about the altitude of an airplane, that is the airplane's height from the ground. What is the vertex's height? So you will start at the vertex and you will draw a 90-degree angle to the opposite side. The altitude is always perpendicular to the opposite side. If you need to pause this while you catch up on the worksheet, that's fine. You can pause this movie anytime you want. Altitudes in obtuse triangles. If you have an obtuse triangle, a triangle with an angle more than 90 degrees, the altitude may be outside of the triangle. So remember, it has to be perpendicular to the opposite side. You extend the side. It goes through the vertex. It will come down outside of the triangle. Altitudes meet at a point called the orthocenter. You need to write that down. The orthocenter can be located inside the triangle or on the triangle or outside the triangle. In the previous example, it was inside the triangle. In this example here, because we have a right triangle, the orthocenter is on the triangle. And in our obtuse triangle, the orthocenter is outside the triangle. We'll work on drawing altitudes and finding the orthocenter. Angle bisectors. Remember, a bisector cuts an angle in half. Angle bisectors will start at the vertex and they bisect the angle. Okay? Angle bisectors have no relationship to the opposite side. In our previous example, we were perpendicular to the opposite side. In this case, we are simply bisecting all three angles. They meet at the incenter, and the incenter is equidistant from all three sides of the triangle. That makes a circle. Any point on an angle bisector is equidistant from the sides of the angle. So you can see that this point here is equidistant from the sides. This point down here on the bisector is also equidistant because it's a bisector. Our next example is the median. The median goes through the middle of the opposite side. It starts at the vertex and it ends at the midpoint of the opposite side. There is the midpoint of this side. The median will go from the vertex through the midpoint. Here is our second side. It will go from the median to the vertex. And the third side. The medians intersect at the centroid. And the centroid is 2/3 of the distance from the vertex to the side. So if you divided this line into threes, this is 2/3, and this is 1/3. this is 5, then this is 2 5s. What would x be if this is 32? 16. The centroid is also the center of balance for the triangle. You can balance a triangle on the tip of your pencil if you place the tip on the centroid. Now, we have the perpendicular bisector. It's a double whammy. It is perpendicular to the opposite side and it bisects the side. It does not go through a vertex. Our other 3 examples have gone through the vertex. So we have to find the midpoint, like a median, and we draw a line perpendicular. So you can see down here we have our median, we have our midpoint, and if we draw a line perpendicular, it's going to run right up and down. Okay? It is the median and an altitude combined together. It cannot possibly go through the vertex. Any point on the perpendicular bisector of a segment is equidistant from the ends of the segment. AB is the perpendicular bisector of CD. It's perpendicular and it bisects. Therefore, we have an isosceles triangle. It makes the circumcenter an equidistance from the 3 vertices. So where the perpendicular bisectors meet is called the circumcenter. We have 6 new terms for you. 8 new terms. So you have an altitude, goes through the vertex, it's 90 degrees, and they meet in the orthocenter. Angle bisector splits an angle in 2 equal angles, and they intersect at the incenter. Perpendicular bisector is 90 degrees. It's a perpendicular line. It bisects the side, and they meet at the circumcenter. And the median is the vertex. From the vertex to a midpoint of the side, and it meets in the centroid. Which one of these is the center of gravity of a triangle? Okay, now on your sheet, you need to label these. The best name for AB. So, this goes from the vertex through the midpoint. What do we call that? This one goes from the vertex and is perpendicular to the opposite side. This one goes from the vertex, and these 2 sides are, this is a trick question because this one is none. I'll tell you. This one goes to the vertex, and it makes an angle bisector. This one is perpendicular to the opposite side and bisects the side. Label those 5 triangles, please. Okay, did you get them right? All right, you're done with the worksheet, but here are some ways that this is used. If you ever hear the term triangulation with GPSs or other things, this is what it's all about. You're stranded on a triangular-shaped island. The rescue ship can only dock on one side of the island. You don't know which side. At which point of concurrency would you set up a camp so you are an equal distance from all 3 sides? So you need to go back through and see which scenario sets you up to be equal distance from all 3 sides. Is it the centroid? Is it the circumcenter? The orthocenter? Pause the movie, go back, and find the answer. It is the incenter. What if the ship could only dock at one of the vertices? Would you change the location of your camp? If so, where? Which of our scenarios has you equidistance from the 3 vertices? Okay, you would set yourself up to be at the circumcenter. Okay, here's a good one. Where would you place a fire hydrant to make it equidistant to the houses and equidistant to the streets? Okay, so we're going to set up an angle bisector here, and we're going to set up a perpendicular bisector between the houses. Where those two lines meet is where the fire hydrant will go. Very good.